Welcome to How to Decipher CX Packet Weights and Control Parallelism. This is the June 2018 version of this for the recording. And I am Kendra Little from SQLWorkbooks.com. I really enjoy topics like digging into how parallelism works in SQL Server and also how to interpret and tune parallelism. We get some interesting weight types from this, and they're a little tricky, as are a lot of weight types in SQL Server. So we're going to dig into a lot of that today. First up, we're going to look at configuring MAXDOP, which sounds like a really simple thing, but there are now so many ways that we can configure the max degree of parallelism that it's actually kind of amazing. And then you get into, well, what if I do multiple of these? Which one actually wins? Which ends up being quite interesting. We'll also look at how another setting, cost threshold for parallelism, how this works, how it interacts with the max degree of parallelism, and can we force queries to go parallel? The answer to that is sometimes we can force queries to go parallel. We will look at different techniques for if we've got a query who's not currently going parallel, but we really want it to. Can we make that query go parallel without changing the settings that impact everybody? Sometimes we can, often we can. We'll look at that. And then we'll pull together what we've learned at that point and talk through, okay, how do I tune cost threshold? Given all the information we've got given so far, how do I set this cost threshold setting that impacts my parallelism? I often like to tune the cost threshold for parallelism a little bit before I even know what my final max degree of parallelism is going to be, because these two settings are so related that I often want to tune one of them and then go back and refine the other. I used to leave cost threshold to last. Now I don't. Now I tend to do cost threshold earlier. We'll then talk about what can just prevent things from going parallel. And this is some of the things that can prevent us from being able to force parallelism. Sometimes there can be other reasons we can't force parallelism as well. But these are some of the biggies for it just won't go parallel. And then we'll get into a really fun section where we talk about NUMA, hardware NUMA, as well as a new feature called automatic soft NUMA. We have two different kinds of NUMA, one that SQL Server gets from just looking at the hardware it's running on, and then we have something called soft NUMA we can configure ourselves. We'll talk about why NUMA exists, why it's useful for SQL Server, how SQL Server sees it. We'll look at an example of automatic soft NUMA and look at how it does. And then we will get into weight stats. These are really fun, and fun, by fun, I mean really complicated. We have long had a weight called CX Packet, class exchange packet in SQL Server that's related to parallelism. Now, in more recent versions of SQL Server, this weight has frustrated people for years, because what does CX Packet mean? Should I lower my parallelism? Should I raise my parallelism? Well, maybe. It could be either one. So because of that, the SQL Server team has split this, what used to be CX Packet weights, into two different weights, and given us, it essentially, we're going to look at, in that section, at, okay, how does parallelism work? And what does it mean to now have a CX Packet weight and a CX consumer weight? What are these two types? And that actually helps us better understand what, it's everything that used to be lumped into CX Packet. So what do these weights mean? And is the lowest weight, now that these are split, can we tune queries just from the weight stats, or do we still have to look at other things? Spoiler, the weights are more useful, but I do think we still have to look at other things. I also think it is useful to look at both. The advice from Microsoft was that the intent behind splitting these out was so that we would have one of them that was more ignorable, and one of them, this guy, that CX Packet would represent a problem, and that CX consumer would be more ignorable. I don't completely agree with that. I still find CX consumer weights useful to look at. We just need to know how to interpret them. So we're going to dig into that in that section. And then we will pull a lot of the information together from the day, because there's just a lot of things that go into understanding these weights and tuning this for different SQL servers. There is no simple formula that we'll get to of just apply this formula and everything will work great. There are some patterns, and folks generally do this, but I would hesitate to even call them best practices. I will touch on these are common patterns, but best practice kind of implies that other practices are bad. So we have good practices, but then other practices could be good too for their unique situations. You can actually be quite creative with how you configure max degree of parallelism and cost threshold for parallelism. But you might want to start on a system with one of these kind of good standard patterns, more usual patterns. And then if it's a critical system worth tuning, kind of develop your own way of managing parallelism on that instance. So I would say there are, common good practices, but that doesn't mean that uncommon practices are necessarily bad. And that's why I'm a little hesitant to use the term kind of best practices in this range. Because different systems often have very different patterns, and you can make this work in different ways. First up, configuring MAXDOP. Just all the different ways that we touch this. There are now in SQL Server many different ways to configure how many cores a query is going to use. When we talk about the maximum degree of parallelism, what we're talking about is how many of our logical cores is this query going to get to use? And that also influences how many threads the query is going to get to use. We'll dig into observing how many cores did this use, how many threads did this use. When we configure this, we can set it at the instance level, and we really always should set this at the instance level. SQL Server ships with max degree of parallelism set to 0, and 0 means unlimited. Well, sort of, at the instance level. It means unlimited up to the number of logical processors we have, or 64, whatever is greater. We can also configure this at the database level. Now, in more recent versions of SQL Server, we can actually, for a database, say, oh no, you have a different default. And this can be very useful for situations where we only control the database level. If we think about hosted solutions like Azure SQL Database, I think that's its current name. It changes a lot, right? But if we think of Azure SQL Database, at that level, we have access to a database, but we don't have access to the whole instance. So what if I have an application that I want very limited parallelism on? If I can't configure instance level settings, I'm going to be really, really happy for the option to set it for my database in some cases. We've since SQL Server 2008, I believe, we have had the ability to set MAXDOP as something with resource governor. Now, we can't do this in every edition of SQL Server, but this has been something that can be very useful. There are some things that have become more simple, like used to for DBCC checkDB. We couldn't actually specify parallelism when we executed the command. In more recent versions of SQL Server, they've added that in. So you could say, okay, here's what I want you to do for this. Used to resource governor, when we didn't have the ability to specify on the command, resource governor was a big way to do that. But we might have applications where there's certain parts of the code where we can't use a query hint, and we don't want to change it for the whole database, and we don't want to change it for the whole instance, but we do want to change the number of cores that certain people are using or certain processors are using. And resource governor is a way to do that. It's really wacky how it's implemented, though. We're going to see that things get really weird when we control DOP with resource governor. So as we look at this, we're going to look at our execution plans and see what does parallelism look like in these. How many threads is it using? How does it perform, etc. So with that, we are going to switch on over to our demo environment that I'm using today. I am using a different demo environment that I sometimes use because I did want to have an environment, like a lot of times I present on a simple VM with just 4 virtual CPUs running on my laptop. But I wanted to be able to show automatic soft NUMA. And automatic soft NUMA will kick in on a virtual machine when there's 8 or more logical cores. We're going to kick into that later. So I'm running here a VM running on a desktop that I've remoted into. And the desktop has 12 cores. It has 2 physical cores, or actually let's switch over and look at it. Now I haven't let's take a look at the desktop that we're running this on here, just so I don't get this wrong. This is just Windows right here. So, oh yeah, we've got one socket. We've got 6 physical cores. I was like, yeah, there's only one socket. I'm remembering this wrong. One socket, 6 physical cores. There is hyper-threading, so there's 12 logical processors. I have given this virtual machine, which is just running on Hyper-V, I have given it 10 logical processors, and it is named derp derp, just to make it really clear that this is not a production instance. Well, what do I currently have this set at? For the purposes of this demo, I have started with a very simple configuration, and we can read our setting for max degree of parallelism from the sys.configurations configurations view. We have MAXDOP is currently set to 4. The value in use is 4. So it has been reconfigured. This is technically an advanced option. So when we're first, and I really think this shouldn't be an advanced option because the value that SQL Server implements by default for this is not a good value to run with. And for years, Microsoft has said, hey, yeah, in most cases, running with this MAXDOP of not configured, of as many logical processes as you see up to 64, that's not the best configuration, but still install doesn't set us for it. To change this, we need to show advanced options and then reconfigure if we're changing this for the first time. Before I ever run reconfigure, I especially in a shared environment, which this is not, but in a shared environment, I always like to look at sys.configurations and check for rows where the value isn't equal to the value in use. And this says, show me everybody who's pending reconfiguration. Right now, I don't have any items who are pending reconfiguration. If I want to change the max degree of parallelism, I am going to need to set something that can be reconfigured. But if I, if I want to change show advanced options, let's do that and say, okay, let's not look at advanced options. Now it will show up as, okay, you're going to change this to 0, but right now it's still set at 1. And that gives me the opportunity, if I don't really mean it, I still want to see advanced options, I can just put it back and make those match. So let's set max degree of parallelism to 2. Now this will show as a pending change. The value in use is 4. I'm going to set this to 2, and I'm going to reconfigure it to make that the real setting. And I'm not saying that I need max degree of parallelism as 2 for this instance. That's just, we're going to compare different ways that MAXDOP is implemented. And right now we have our instance value at 2. We're going to run a test query here. It's using the Babby named sample database. And what I've done is, if I scroll up a little bit here, I have already run this setup script that comes with the demos. And I just opened the script I'm already in. So we will actually open the setup script here. It's OO setup. This is in the zip file of scripts. And what it does, it gives you a link to release the Babby names database. And this actually has an incorrect, it should be V3 right there. So there was one piece of that script that I meant to change. We are actually using the release version 3. And let's make sure now that this link actually resolves to something. We're going to put that in there. I think it's, yeah, let's look at all our releases. I misremembered that. I think it might just be our latest release here. It's 1.3 is our latest release. So let's go ahead and click on that release and copy that in there. Sorry about that. So the database backup I'm using is actually the latest database. So this did not copy and paste properly. Let's fix that. So I'm switching between the Mac and the Windows world is what's going on here. And there we go. It's the battle between using control and using the command to copy and paste. So sorry about that. I will fix the uploaded file during the first break. This is the 1.3 release. You'll get very similar stuff from the earlier release. You just won't have more recent name data in there. Our script restores that database. I have memory set at about 9 gigs-ish for my max server memory on the SQL server. Things like your server memory can impact the choice of execution plans you get, as will the number you're setting for cost threshold and MAXDOP, as we'll see. But we basically restore the database. I add some data files, and we're going to expand the data a little bit at the bottom so that it'll use those data files. So this takes about 5 or 6 minutes to run on my instance. I have already completed that. All right, so let's actually look at a query in this database. We're going to look at a couple different, literally a couple different sample queries today, and this is one of them. I'm going to turn on my actual execution plans using this button up here to tell SQL Server to show me a map of how it executed this query after it completes. This query is looking at a table called DBO first name by birth date, and that table has one row for every baby born in the United States in a given period. It has quite a few rows. So the main thing to know about this query is we're looking at quite a few rows for a specific first name that we're joining to ref.firstname first name to find, and then we're doing an aggregation based on gender. So tell me how many Jacobs there are in the entire table based on gender. And this may be a sign of data entry errors, or it may be that there are more than 600 Jacobs, but we do have a lot more male Jacobs than female Jacobs. But we are looking at a lot of rows to get this. If we look at our execution plan, I have just clicked on this tab here. One of the ways we can tell if our query has gone parallel is these little double arrow lines on all the operator indicate that this operator is parallel or is related to parallel. It is in some way using more than one of our logical cores. These operators who do not have double arrows on them are single threaded. We have different zones in this query execution plan. Notice that our clustered index scan over here, when we got the data from the ref.firstname table, it just used a single thread to do that. And then it goes into a distribute streams operator. I have one core being used over here. I want to use multiple cores in these operators. So I need to have a way to take the data that's coming in on a single core and allow multiple cores to work on that data in the zone over here. So we can actually see that we have a whole zone defined by distribute streams and gather streams there. We are doing another piece of data access here. We can access data. We can pull data out with multiple cores. This clustered index scan, which is against the DBO first name by birth date table, that one has a lot more rows. And SQL Server said, oh, I actually would like to get that data out with multiple cores for that one. We're going to join the data between the two tables with a join operator that also used multiple cores. We can join data using multiple cores. We don't have to just use a single thread to do that. And in addition, we can aggregate the data with multiple cores. Due to the nature of our query, SQL Server decides, hey, we're going to go back to single threaded over here. In this actual plan, we can see a lot of information about the parallelism. I'm going to click on the select operator and right click and say, look at the properties. And when I look at the properties of this select operator, this is at the far upper left of the plan, I can see a lot of information about the whole plan on here. If I zoom in on my properties, I can see that my degree of parallelism for this was 2. I have this set at the instance level. This query does not have any hints in it. So it looked at the instance level setting for the max degree of parallelism, and the query also qualified to go parallel. We'll talk more about what it takes to qualify to go parallel. It qualified to go parallel, and so it executed using 2 cores. When the max degree of parallelism controls how many cores are you going to use and what cores will be used. We may use way more than 2 threads. Let's look at what's called query time stats. These query time stats are something that we now have in execution plans, but we only have them for more recent. So a lot of these plan properties have been added more recently. And so not only does the version of Management Studio that you're running matter, because Management Studio needs to be able to recognize these things in the execution plan XML, but the version of SQL Server that you're running against needs to actually include these in the execution plan too. I believe it is SQL Server 2014 Service Pack 2, I believe, where the engine version starts telling us things like query time stats. For this entire query, my total CPU time was 7 seconds at MAXDOP 2. my elapsed time was close to 4 seconds. We'll be able to see on individual operators more detail about query time stats as well. Let's say I click on this, who should we pick? Let's pick the hash match join. I can click on actual time statistics on this and expand the CPU time on it. So now I'm on the hash match operator. And when we look at this information, we can see we were running at MAXDOP 2. There are 3 threads that are reporting CPU time and 3 threads that are reporting elapsed time. With these little parallel operators, we have what's called a controller thread, and that's the little thread 0 there. It is saying, okay, I've got 2 threads who are doing the work, thread 1 and thread 2. Okay, are you done yet? Are you done yet? Are you done yet? How are things going over there? It's not burning a lot of CPU. It's just a little bit of overhead that we have during the parallel. But we can see that these threads spent similar amounts of CPU time. They're not perfectly balanced. They didn't each do the exact same amount of work, but it's pretty close. And that's good. That's not guaranteed. There might be some cases where some thread or threads do way more work than other threads, and everybody kind of has to wait until that thread doing work is done because there's still data coming through from it. This parallelism is pretty balanced. We can also see in our actual I/O statistics, if we go into actual logical reads, we can see, and this is a hash match operator, so they are not doing logical reads here, and we don't even have physical reads. But on something like if we go down to our clustered index scan here, we can see for the threads, for our DOP, exactly how many rows they found. And sure enough, this thread actually worked on more rows than the other thread did. So even in the actual I/O statistics, it is broken down for us based on the degree of parallelism. And we can see not just how much CPU time did they burn, but actually how many reads did they do. We can even see these asynchronous prefetching for read aheads we can see by thread as well, which is very, very cool. So one of these guys did more prefetching, like kind of vacuuming up data into memory as fast as it can ahead of the read, sort of grab that data into memory for fast access. Very, very cool that we get this detail now. Another thing we can see back on the select operator is thread stats down here. So now I'm back on the select operator. And looking at thread stats, I can see the number of branches in the plan. This is actually the number of branches in the plan that can execute concurrently, because different parts of this plan may be able to do some operations at the same time. I can also see my thread reservations. So I ran at MAXDOP 2. It's going to do all of the work on 2 cores. But threads can trade work on and off those cores. The SQL Server OS manages how many threads do I have, or how many threads am I going to get, and then it has a way of saying, okay, I'm going to rotate these workers. They're going to use different techniques. They yield. Nobody wants to run for too long. I'm going to rotate them off the cores who this query is running off of. So I did have 4 threads reserved for this query. We actually only used 3 of the threads. So just because I reserved 4 threads doesn't mean I used them all. The higher my MAXDOP gets, we're going to see this, the more threads I can use. And on a very busy system, this can really matter, because there are settings like max worker threads in SQL Server, where if we have tons of queries using tons of threads, if we have a lot of concurrency and there's lots of thread use going on, we don't want there to be just bazillions of threads created, because we could actually overwhelm our operating system depending on how many total cores we have. This isn't super common to run into, but there are times when folks actually have issues where it's like, oh, we're using all our worker threads, we can't create more. And they're tempted to do things like just raise the number of worker threads SQL Server can create, which might solve a problem short term, but might also lead to a greater problem of just overwhelming that system with threads. We can control the number of threads used in part by configuring MAXDOP. And one big thing is not just going with that value of 0 of use all the cores you've got up to 64. and then also controlling who gets to go parallel. Other things like blocking can play into this too. If I have a lot of blocking on my system and I have a lot of queries running who can't do anything, they're just stuck, they may be using a lot of threads. Blocking can cause more queries to be concurrently running than others. So there are many things I can look at with those worker threads, but one of the first steps of just never getting the problem is to think about how you configure your parallelism. So it's a good reason to think about this stuff. All right, so with MAXDOP 2, we reserved 4 threads. We used 3 threads. Well, let's go ahead and change our MAXDOP. Now I'm going to change it to 8. I have 10 cores, and we're going up to 8 in this virtual machine. Now that I have changed MAXDOP to 8, we're going to go ahead and rerun this query here. Let's go ahead and full screen this guy because we'll be here for a little bit. And when I run the query again, one effect is that my query is faster. I have 1 second of execution time here. Let's actually time this by looking at our properties here. Our query time stats say elapsed time is 1.6 seconds. CPU time is 9.8 seconds. CPU time, if I have parallelism going on, CPU time is the total of all CPU usage by all the cores involved in this. So all 8, I can use 8 cores in this query. All of the CPU time, used by the 8, which a lot of it was concurrent, is added up. And that adds up in this case to, what was it? Almost 10 seconds of CPU time, but only 1.6 seconds of elapsed time. When I run this query at MAXDOP 2, if I switch back to MAXDOP 2, my duration for this query is longer. It's for this query, and this doesn't happen for every query. Higher MAXDOP does not always equal higher speed. At some point, this evens out, and I have seen some cases where even higher MAXDOP, a query can start to slow down. This tends to be on, large hardware where the query is doing a bunch of data access, and there is a point on some of these systems where if we're going outside of a NUMA node, which we'll talk a little bit, but if we're using all the cores and the cores aren't all in the same place physically on the hardware, things can even slow down because we're starting to do a remote memory access that's slower. So in this case, higher MAXDOP is faster. With MAXDOP 2, we're at 3.4 seconds of execution time, but less CPU time, 6.5 seconds of CPU time. So our CPU time's a little cheaper. Our duration is twice as slow. If I go to MAXDOP 8, I am burning more total CPU, but my duration is slower. Interesting thing to think about is that we license our SQL Server by CPU power now. We used to license by the socket. Now we license by the core. So the amount of CPU we're burning, it doesn't matter that much when our systems are small, but then starts to get more and more busy. And okay, so we're having all greater and greater CPU use. Our CPU usage goes up. Do we need to add more processors? Well, that's going to be expensive. Even if it's a virtual machine and it's not a big deal to add the processors, depending on our licensing, however we're doing the licensing, if we don't have unlimited licenses for our VM, that can be expensive. An alternative is to tune MAXDOP and control more who uses CPU and how much CPU are they using. We still want to pay attention to making our queries fast, usually. There are some cases where people are like, yeah, it can be slow, we don't care. But those aren't the systems where we're usually doing much tuning. All right, back where we're at MAXDOP 8. This query ran on MAXDOP 8, and notice that the operators look the same. We still have 2 arrows. Just because we ran at MAXDOP 8, we do not get additional arrows on there, but I like to imagine additional arrows on there because a lot of these operators, it's not really one operator going parallel. I'm at MAXDOP 8, so it's really for this hash match operator, it's really much more like I have 8 of these hash match operators acting independently, and then they feed into this parallelism operator, but it's just pictured as one operator with double arrows on it. So I actually do like to picture additional arrows when I know what the degree of parallelism is. Clicking on our select operator here, we can confirm, indeed, we did get MAXDOP 8 from the instance settings. And looking down at our thread stats, yes, we did get more threads. we used 9 thread. We still have the same number of branches there, but looking at our thread reservation, we reserved 16 threads, which not coincidentally is the DOP times 2, right? Our degree of parallelism, or DOP, is 8, and we reserved 16 threads. So on each of those, we're going to use 8 cores. Each of them can be doing multiple things, but we were able to reuse some of these threads. We actually only ended up using 9 of these threads. Now, when I go into my individual operators, let's look at the clustered index scan. When I expand my actual time statistics, I see 8 threads and a controller thread there. So with my DOP, the work got spread out on more different workers. They could do the work at the same time for the parallel operators. I'm still amazed by the number of details that we can see here. Now, one note about actual time statistics. I am right now on this clustered index scan operator, and notice that it does not have a child operator. It feeds up into here, but there's nobody feeding into it. For this operator to interpret what do these actual time stats mean and the elapsed time and the CPU time, one of the things I need to know is what the execution mode is, because these can be for some operators, if they have children. This one doesn't have a child, so it's not going to matter. But I do generally want to know in general, is this in row mode or batch mode? Batch mode operators can work on more than a single row at a time. They can actually do chunks of operations. At this point, we can only get batch mode if our queries are referencing a table that has a column store index on it. It doesn't have to choose to use the column store index, but there just has to be one of the tables, one of these 2 tables in this case, would have to have a column store index on it for us to be qualified for batch mode. The SQL Server team has told us that they are going to be soon introducing the ability to have batch mode with only row store indexes in new versions of SQL Server. So I do expect that to change soon. So this operator's in row mode. Also, it doesn't have any children. So for this operator, this total elapsed time and CPU time is just for this operator itself. So it took 1.5 seconds total to pull the data out of dbo.firstname by birth date. And that is almost the entire runtime of the query. Most of our time is being spent doing data access here, which does lend credence to the fact that there is a suggestion that we could reduce the estimated cost of this query by 99.8% if we provide an index, which the index it suggests may or may not be the exact index we want. Question, is row mode always the default option unless it has a column store index? Yes, at this point it is. I am looking forward to that changing soon, because in a case like this, where we are just scanning this and dumping it into a join, this is one of those queries where, yes, if we provided an index, we could help it too, but also using batch mode could speed this up a bit as well. So yeah, right now we will only get row mode unless we have a column store index, but looking forward to more exciting times in the future. This hash match also happened in row mode because we don't have a column store index. Now the hash match does have children, right? The hash match has things feeding into it. I said people, they aren't people. It has operators feeding into it. So when it has, if you're in row mode and you have child operators, in that case, your actual time statistics and your actual elapsed time is for you and your children. This hash match itself did not take 1.5 seconds. It's getting, well, let's go to the actual hash match. Let's click on the actual hash match. The actual time statistics for the hash match are 1.6 seconds. That includes the time it's getting from both branches. So to figure out, oh, well, how much actual time did the hash match use? We would have to figure out how much time was used by all the children. We've already identified that this clustered index scan is 1.5 seconds of the query's total runtime. So really a little bit of time is being spent by the hash match. So that is part of the trickiness of interpreting the per thread stats on the hash match is if it's a row mode operator and it has children, these are the thread stats for it as well as the children. So very, very cool that we can see that as well. All right, so we've tested MAXDOP 8 and we've tested MAXDOP 2. Right now, our instance level configuration is at MAXDOP 8. What if we set the database configuration for our database? The DMV that will help us see has MAXDOP been set at the database level is named sys.database scoped configurations. How do I know if a DBA or developer set this at the database level? I'm going to have to know to go and look, or they are going to need to document it for me, because most of us are not used to it being set here. Folks who've been working with SQL Server for a while, they're used to configuring MAXDOP through spconfigure. They're used to using hints for MAXDOP, but most of us wouldn't think to look, has MAXDOP been set for the database? Right now in sys.database scoped configurations for my current database, which is our sample database, we have this set to 0. And if it is set to 0, which is the default value, that means I will just go with the instance configuration. There is also a way that we can configure this for secondary instances, and that would be an availability group secondary, or maybe a specialized type of secondary we can configure in Azure. If we have a readable secondary, do we want the same degree of parallelism on that database as we have here? Now, if we've set up our own availability group and we're managing the instances, we might want to just manage that through spconfigure on the secondary instance. But we do have the ability to set it here, and it's kind of cool because it is aware of who's the primary and who's the secondary. So I'm actually, I think this is a kind of cool option. The biggest thing to worry about with this option is that it is unusual, and if you use this, you need to just document why you've used it and the fact that it's there, so that other people who come along and troubleshoot this don't get suddenly confused about, like, oh, why do we have a different DOP than the instance specifies? What's going on here? To change the setting, we just say alter database scoped configuration, set MAXDOP equals whatever we want MAXDOP to be. So I'm going to set it to 4. Our instance configuration is still 8. And now that I've changed this, I can see I don't have a reconfigure to run for the database level one. Just as soon as I run this, it is the value in use. And now it says this is not the default value. So it is immediate after that command completes. Looking at my actual plan now, I am in this database. The database is set to MAXDOP 4. So I should get MAXDOP 4 because the database setting overrides the instance level setting, unless the database setting is set to 0, which means use whatever the instance level is. My query plan, notice the shape has changed. My query cost is actually a little different. My estimated subtree cost at DOP 4 is 547. Looking at my properties, we can confirm that I did get DOP of 4. The database setting won over the instance setting. That is good. That is expected. And looking at my thread stats, well, let's look at our reservation there. We reserved 8 threads this time. We actually used 5 of them. What was our query time stats? Our elapsed time, it's faster than when we were using 2 cores. It is slower than when we were using 8 cores. And the CPU time is not as much as when we used 8 cores, but it is more than when we used 2 cores. Using a higher DOP for this query is burning more CPU time, but bringing down elapsed time for the query. We can reset this at any time by just setting it back to 0. That says use the instance level configuration. And as soon as I set it back to 0, I can see that it is back to the default value. I still haven't messed with my secondary one here. So this is this can be used to solve problems, especially, I mean, thinking about I might have the type of database instance where I have lots of different customers and they have different amounts of data in the databases, and there isn't a degree of parallelism that is good for them all. This might be a way to have a lower DOP for, like, set the instance level to generally what is better for small databases and give them a lower DOP. But for my 1 or 2 big customers on the database, I could raise their DOP. If they go parallel, they can use more cores because they pay us more money, right? Or this could be useful for that, but just really, really document it very clearly, because folks generally will not think of looking for database level MAXDOP at this point. So I like that we have this. It's one of those new features that is also SQL Server 2016 and higher only. So there may be some cases where you don't use it because you aren't on SQL Server 2016